So have you ever wondered how a tiny little link from a service like Bitly can handle billions of clicks? It's pretty amazing, right? Well, today we're going to break down one of the most classic, you might even say iconic, system design interview questions, how to build a URL shortener from scratch. We're going to walk through exactly how you should approach this, from that first intimidating question all the way to a final super scalable design.
All right, here's our game plan. We're going to tackle this just like you would in a real interview. First up, we'll nail down the challenge. Then, and this is key, we'll ask some smart questions. After that, we'll build a simple blueprint, get into the really cool part, generating that magic link, and finally, we'll crank it up to 11 and design this thing for massive, massive scale.
Okay, let's get right into it. So, picture the scene. You're in the interview, the pressure's on, and the interviewer gives you a prompt. It sounds simple, almost too simple, but don't be fooled. This is a test of your entire way of thinking.
How would you design a URL shortener service, like Bitly? You know, on the surface, this feels kinda easy. But let me tell you, the interviewer isn't looking for a few lines of code. Nope. They are testing your ability to think big. They want to see, how do you handle scale? How do you make sure the service never goes down? How do you make it lightning fast? And maybe most importantly, can you talk through the trade-offs you have to make? That's the real test.
All right, here's where so many people go wrong. The absolute biggest mistake you can make is to just grab that whiteboard marker and start drawing boxes. Don't do it. Before you put on your engineer hat, you need to put on your product manager hat. The first, most critical step is to ask questions. You have to clarify exactly what it is you're supposed to be building.
Okay, so when we break it down, we have our functional requirements, what it does, and our non-functional ones, how well it does it. But look closely here. See that? There's a hidden battle happening on this slide. We need analytics, right? That means we have to see every single click. But we also need super low latency, which usually means we want browsers to cache the result and, not talk to us again. See the problem? This is a classic system design trade-off, and we're going to need a really clever solution to get the best of both worlds.
So when we say massive scale, what do we actually mean? Let's throw some real numbers at this. Let's say we're aiming for 1 billion reads a day. If you do some quick back-of-the-napkin math, that works out to an average of 10,000 requests every single second. 10,000! And remember, that's just the average. During a big event, that number could spike way, way higher.
Okay, here is probably the single best piece of advice for any system design interview. Start simple. Seriously, don't try to build the Death Star right from the get-go. Let's create the most basic, bare-bones version of this service. Something that just, works. Then, once we have that foundation, we'll start adding the heavy artillery to make it scale.
When you strip it all down, what is this thing? It's really just a giant key-value store. That's it. The short URL is the key, and that big, long, ugly URL is the value. So our service has two jobs: either create a new key-value pair and stick it in a database, or look up an existing key to find out where it's supposed to go. Simple as that.
And how does a client talk to our service? Well, through two really simple API endpoints. To make a new short link, we'll use a post request. Why post? Because we're posting new data to the server. And to use a short link, we'll use a GET request. Why GET? Because we're trying to get the long URL back. This separation of creating things versus fetching things, writes versus reads, is a really fundamental concept.
Okay, now we get to what I think is the most interesting part of the whole problem, the secret sauce. How do we actually create that little magic link, that short, unique, kind of random-looking code? This is where we get to flex our algorithmic muscles.
And the answer is this brilliant little trick called base 62 encoding. Now think about how we normally count. We use 10 digits, 0 through 9. That's base 10. Base 62 is like that, but on steroids. It uses 62 different characters, all the numbers, all the lowercase letters, and all the uppercase letters. And just look at the difference that makes. If we have a 7-character code in base 10, we get 10 million combinations. Not bad. But in base 62, that same 7-character code gives us over 3.5 trillion possible combinations. I mean, that's just a whole different universe of scale.
So how do we actually generate the string that we're going to encode? Well, you've got two main paths you can go down. Strategy 1 is hashing. You take the long URL, run it through a hashing function like MD5, and just grab the first 7 characters. It's super simple.
The downside? There's a tiny chance you get a collision where two different URLs produce the same hash. Strategy 2 is using a counter. You literally just have a number that goes up 1, 2, 3, 4, and you convert each new number into base 62. This is great because it guarantees every link is unique, but it also means you have this one single counter that the whole system depends on, which could be a bottleneck. Again, it's a trade-off and you need to be able to talk about it.
Okay, so our little blueprint is cute. It works for maybe one person. But what happens when we throw 10,000 requests a second at it? It's going to melt. So now we get to the most important part of the interview. This is where you really show your skills. We're going to take that simple design and evolve it into something that can handle real, internet-level traffic.
Let's be honest, the first thing that's going to break is our database. It's the most obvious bottleneck. Think about it. Our system is mostly people clicking links, so it's super read-heavy. Asking a single database to handle 10,000 read requests every single second, plus all the new links being created, it's just not going to happen. It would get completely overwhelmed.
So what's the solution? Caching. It's the classic answer for any read-heavy system. We can stick a super fast in-memory cache, something like Redis, right in front of our database. The flow becomes really simple. A request comes in, we check the cache first. If the answer is there, that's a cache hit. We send it back immediately. We're done. Super fast. If it's not there, a cache miss. Okay, we have to go to the slower database. But here's the crucial part. We grab the answer, and then we put it in the cache on the way out. That way, the next person who asks for the same link gets a super fast response.
Okay, remember that conflict we talked about earlier? Analytics versus speed? This is where it comes back to bite us. If we used a 301 permanent redirect, we'd be telling the user's browser, hey, from now on, just go straight to the long URL, don't bother me again. That's great for the user, but it's terrible for us because we can't track any more clicks. So to get our analytics, we absolutely have to use a 302 temporary redirect. This forces every single click to come back through our servers. It means more traffic for us, but it's the only way we can count every hit.
But wait, if every single click is hitting our server, we can't be writing to our main database every single time. A popular link could generate thousands of writes a second and would just bring our database to its knees. So the solution is to do it asynchronously. Here's how it works. When a click comes in, our main redirection service doesn't touch the database. It just shouts the event into a message queue, like, hey, link XYZ was just clicked. Then we have a completely separate analytics service that's just listening to that queue. It gathers up all those clicks, counts them in memory, and then only once in a while, say every minute, it writes the grand total to the database in one big batch. This shields our main database from that crazy storm of writes.
And here it is. This is what our final robust, scalable architecture looks like. Let's walk through it. A request comes in and first hits a load balancer to spread out the traffic. Then it goes to an API gateway, which is like a traffic cop, directing requests to the right place. And notice we've split our services. We have a URL redirection service that only handles reads, and it's protected by that huge cache we talked about. Then there's a separate URL shortening service for writes, which gets way less traffic. And off to the side, our analytics service is just chugging along, processing all that click data in the background. See how everything has its own job? This is a beautiful, scalable design.
Look, if you can lay out this design in an interview, you're going to impress them, for sure. You've solved for scale, you've solved for availability, you've solved for latency, but to go from a good candidate to a great one, you have to think one step ahead. What would you build next? What's the next feature? Maybe custom URLs, like bit.ly/myawesome-link. Or what about links that automatically expire after a week or after 1,000 clicks? Showing that you have that product vision, that's the real home run. So what unique feature would you add to make this thing stand out?